Let's begin. Today's November 11th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 6, 9, 15, 16, and 20. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So on the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally, criteria card E. So criteria card A takes a look at our middle digit, the square digit, and the Turing Machine will let us know whether its value is an even digit or an odd digit. Criteria card B takes a look at our 3-digit solution, and the Turing Machine will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2, maybe even all 3 are 3. Criteria card C will take a look at our 3 digits, triangle, square, and circle, and the Turing Machine will let us know which one is the absolute largest. Should triangle be the largest? Should square be the largest? Or should circle be the largest? Criteria card D, again, we'll take a look at our 3-digit solution, but this time it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? And finally, criteria card E, again, we'll take a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. There are 3 cases, the first one being that our solution may have no repetitions, as in the example 125, or the Turing Machine can let us know whether there's a double number, as in the example 112, or finally, the Turing Machine could tell us that it's a triple number, basically a single digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I'd like to test is criteria card A. Okay, so the Turing Machine does not approve of my choice for square. Notice that I did pick an odd 1. Since the Turing Machine does not agree with that, it's letting us know that the square digit should actually be an even digit. So let's go ahead and type that up in our notes for section A. And again, we'll say that square is an even digit. And since it is an even digit, let's go ahead and cross out all of the odds in square. Okay. Let's see, what else do we have? Let's go ahead, let's see. A lot of good choices. Well, we already have a single even digit in square. Let's go ahead and see what criteria card D tells us. Okay, so the Turing Machine does not approve of my choice of 314. In criteria card D, we're looking at the ratio of even to odds. Notice that in my proposal, I've got 2 odds to a single even. The Turing Machine does not agree with that. So in fact, it's letting us know that there should be more even than odds. So let's go ahead and type that up in our notes in section D. And that again is that there should be more even than odds. Okay, so obviously, since there are more even than odds, at a minimum, we know that there should be 2 evens. And I am wondering, well, I know we can't have 3 evens, because if we had 3 evens, there would be no 3-digit, but I'm not sure how that would work. I know we're not going to have 3 evens, but technically there's not an official card that is counting the number of evens. So I'm not sure if that's how that's going to play out. So that means that if I do have two evens, the question is, are they going to be paired up? What else? We also have criteria card C, letting us know which one is the absolute largest. So if we do have a pair of evens, it could be that that odd digit is going to be the largest, because typically when you have pairs of digits, whether it's the largest or the smallest, it's not going to be the one that's paired up. So let's see. You can have a pair. I'm trying to think of how, if I want to test whether they're all distinct, or do I want to test which one's the largest? Very interesting indeed. Man, I'm not sure. So currently my circle digit is the largest in my proposal. How can we anticipate what could be happening if we have no 3? Then it could be that the odd is a 5. But where would it go? Also notice that our, even though, criteria card C does reference all the digits, I guess technically only criteria card C mentions anything about triangle or circle. Only one of those will be correct, if at all. Maybe it could even be square, but very doubtful. So there's going to be one digit that's sort of missing, and therefore you can think of it as being forced into a particular value. So it could be that you do have a pair of evens. If that's the case, you could have either 2 2s, and then either the 3 is the largest, or perhaps 5 is the largest, or you could have 2 4s and have 5 be the largest. So it could be that we're looking, maybe we do have a pair of evens. The question is, which one's the largest? Let's see. Well, let's just make a call. Let me go ahead and test criteria card C. Okay, wow, lucky break. So again, in my proposal, circle is the largest. So let's go ahead and type that up in our notes in section C. And we'll say circle is the largest digit. And let's see what we can discover from that. Well, if circle is to be the largest, I don't think it could be a 1, because then what would triangle and square be if that's the largest? And I think triangle, I don't think triangle could be a 5, because if triangle is 5, there's nothing larger for circle to be. So let's go ahead and cross out the 5 for triangle. Okay, so triangle can't be a 5 either. And so, let's see. Yeah, I think that's about it. I don't think we can cross out anything else. Let's see. So we do, again, remember, we do have a majority of evens. So it's either going to be a 2-4 sort of possibility, and then an odd, or, yeah, at this point I think it's safe to say, yeah, you can't have, well, can you have 3 evens? Again, based on the discussion earlier in the video, I know we can't have technically 3 evens because, again, that would lead us to believe that you'd have no 3s. But again, there's nothing in gameplay that sort of, hints at that. But if we do have a pair, again, it does have to be even. Yeah, I don't think two 2s and a 4 is gonna be it, but let's just be open-minded about it. Well, I think that does it for this round, though. We did do our 3 Turing tests, and we're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card B, letting us know how many 3s there might be. At this point, if there is an odd, it's either 3 or not. And then we also did not test criteria card E, letting us know, whether there's a repetition or a double. Okay, so what can we say about square, that even digit? It could be a 4, forcing circle to be a 5, and then triangle is either going to be a 2 or a 4, based on that. Well, that is interesting. Let's see. Let me list that out. So yeah, square is 4. That forces circle to be 5. So we're looking at either 2, 4, 5 or 4, 4, 5, since either that even digit is paired up or not. So that's if square is 4, and that seems to be the only 2 possibilities. Now, what about if square were 2? Well, again, we don't know if it's paired up, so it could be, that one's going to lead to a lot of possibilities. 2, 2 in either 3 or 5. Again, assuming that it's not a 3 even solution. Wow. Well, I think I'm going to leave it there because I think there's just way too many to write out. Let's see. How do you pick between? We have established, let's see. Maybe. So I guess prior to closing out the first round, I think I could have also crossed out circle 2, because if circle were 2 and it's the largest, there wouldn't be anything. Square can be 2 to begin with, so you couldn't even do that. So let's go ahead and cross out the 2 for circle. Now it could be that circle is a 3, forcing triangle and square to be paired up. That's possible. What about if circle's 4, then it could be that triangle and square are paired up, or it could be 1, 2, 4. That's possible. Now, what about circle 5? Circle 5. I don't think, actually, you know what? I don't think circle could be 5, come to think of it. Well, at least not, yeah. Because then how would you pick between 2 and 4? Could it be, even if there were paired up, how would you pick between the pair of 2s and the pair of 4s? I don't see how you have a way to pick from that. And if they weren't paired up, how would you know whether triangle is 2 or square is 2? There's no way to order it. Well, that's interesting. So yeah, I don't think it could be a 5. Because again, you do have a majority of evens. I don't see a way you could pick that. That would have too many ambiguous solutions. So it's down to 3 or 4, and it can't be 4 either. Because you have to, well, no, I guess technically you could have 4, because then you could have a pair of 2s, technically. But how would that work? How would you... Well, I guess if there's a 3 or not, I guess if there is a 3, I don't see triangle being it. It could be circle. I guess if there's a 3, then circle's going to be 3 and you're going to have a pair of 2s. If you don't have a 3, then it's going to be, yeah, I think that's as simple as it is. It's either going to be 2, 2, 2, 3 or 2, 2, 4. Very interesting. So it may be that we just have to do a single test, and that is if there's a 3 or not. That is interesting. Okay, so yeah, so let's do 2, 2. Wow, yeah, let's just do 2, 2, 3. Okay, so just to check, well, let's see. Yeah. Yeah, everything else makes sense. Crossing out the 2 for circle and the 5 for circle. It would just leave too many possibilities. And so I think testing for 3 should be enough. Yeah, we may be able to deduce that there's a pair. I think, yeah. Okay, so let's test 2, 2, 3 and see where that takes us. Okay, so yeah, let's test criteria card B. Okay, so there is a 3, and as I stated, I don't think triangle could be a 3 because, well, oh, hold on. No, I guess you could still have. Well, let's see. If triangle were 3, that would force circle to be 4, which would make square be 2. Yeah, I think you do have to test it. That'll tell us which of triangle or circle should be a 3 if there's a pair or not. Yeah, because either one does make sense. Yeah, and actually, even before, I think we could have crossed out 4 for square, since it can't be the largest. So that means that square is 2. The question is it paired up or not? Okay, yeah, let's go ahead and test criteria card E. Okay, so yes, it does not approve of the fact that I have a pair. So yeah, so we're going to say, well, let's go ahead. I should have written down in my notes in section B that there is a single 3-digit. So we'll say that the solution has a single 3-digit. And but we still don't know which one it is. And then in E, we'll say that the solution has no repetitions, since it did not approve of my double number here. And let's see. Yeah, and I think we can disqualify the triple digit because there has to be an absolute largest. So yeah, there could be only, well, there's no doubles. It didn't like it. And there can't be triples since there has to be a largest. So yeah, so the solution has no repetitions. But we will say we'll deduce that. Okay, so no repetitions, and we do have a 3. So that means circle can't be 3, because that would force that pair of 2s, which is basically my proposal. So yeah, so it can't be circle. So circle's 4, triangle's the only 3 left, and of course, so yeah, so that's the 3 there. So let me go ahead and bring this all the way. Oops, not that. Bring this triangle all the way to 1. And it's not 2. It is the 3. Okay, so it looks like the solution should be 3, 2, 4. Let's quickly type that up. And let's do a quick verification. And so is that middle digit even? It is. The solution does have a 3. The largest, though, is circle with 4, yeah. There are more evens and no repetitions, yeah. Okay, so let's go type it up and verify that 3, 2, 4 is our solution. Okay, fantastic. Well, how do we do versus a Turing machine? Well, it was a 5 criteria puzzle, and we did do 5 tests. So that's always a good indication that at worst we tied with the Turing machine. Well, we did ACD in the first round, and then we did the remaining 2 in the second round. And yeah, so ACD. So A was incorrect, C was correct, D was incorrect. In the second round, B was correct, and E was incorrect. Okay, so we still beat the Turing machine by 1 question. Well, not sure where that was. Maybe the repetitions. I'm not sure, but it was, I think there was a bit of a twist in some sense, in my opinion, but which made it a bit fun. Not being too sure what could happen. Obviously, I started down this line of listing out potential solutions and then discovered that there might be way too many to list out. And so, how about you? How did you solve it? What criteria cards did you choose? In what order? And did you notice anything interesting? Add your thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.